Section 1.8 is about perimeter, circumference, and area. So if you remember, perimeter is the distance all the way around it, so you just need to add up all the side lengths. The area depends on the shape for what formula you will use. For a rectangle and a square, you can just do length times width or base times height. For a triangle, you have to do a half times base times height. And then for a circle, the perimeter is now called circumference. And you have two different formulas, but it depends on which one they give you to determine which one I would use. Meaning, if they give you the radius, I would use this one where I do 2 times pi times radius. If they give me the diameter, I would use pi times diameter. And then the area formula for a circle is pi times radius squared, so you always need radius for the area. So let's take a look at some problems utilizing some of those. So in this first one, it gives you the botany club members are designing a rectangular garden for the courtyard of your school. They plan to place edging on the outside of the path. How much edging material will they need? So I went ahead and I tried to label stuff because the picture is kind of hard to see, but you should be seeing that the inside garden is 16 by 22 feet, and then they are wanting to put a 4-foot edging material all the way around. So they're asking how much edging material. So the first thing I did was come up with my new dimensions for the width and the length. So if I was going to find my new length or my height, I would have to add on 22 plus this 4 and this 4 because I'm adding an extra 8 feet total, 4 on each side. So my new height would be 30 feet. Same thing for my width. My width was 16, but again I'm adding 4 feet to both sides, an extra 8 feet. So I would have 24 feet as my new width. So then if I'm wanting to figure out how much edging material, all I would need to do is find the perimeter of this rectangle. So now I would be using my new dimensions. So I would be using 24 and 30, and I could add up all of those sides. So I added 30 plus 24 plus 30 plus 24, and that's how I'm getting 108 feet. So I'm going to ask you to read through the next question and see if you can do the got it question. So in the got it question, it says you want to frame a picture that's 5 inches by 7 inches with a 1 inch wide frame. So I always draw a picture to get started. So I drew my picture, which is 5 by 7, and then I'm adding an extra inch on each side for my frame. So when I was finding my new dimensions, I would have to add an inch to both sides for my width, so that's why it's going to become 7. And then I would have to add an extra inch to both of the sides for the height, and that's why it would become 9. So when it's asking me to find the perimeter of the picture, I can just add up 5 plus 5 plus 7 plus 7. So my picture was the inside rectangle, so that's how I'm getting 24 inches. For the perimeter of the outside frame, that's where I'm going to use my new dimensions, and I'm going to add 7 plus 7 and 9 and 9, and that's how I'm getting 32 inches. So if you're struggling finding these, please make sure that you're asking questions. So pause the video and get my attention so that I can come help you. Alright, let's take a look at some of the other formulas. So some of the other formulas involve using circumference and area. And so this next problem is saying, what's the circumference in terms of pi? What's the circumference of the circle to the nearest tenth? So you're using the circumference formula, but how you finish the answer determines on the question. So for this case, the circumference formula was either 2 pi r or pi times diameter. In my first problem, they're giving me the diameter. So therefore, I would be using that second formula since they give me the diameter. So if I was going to plug in my 15 for the diameter, if I leave my answer in terms of pi, that means you ignore the pi symbol and do any multiplication that you can to simplify. Do that number and then just tack on the pi symbol at the end. So we're not looking at pi as being a number right now. So instead, I look at it as in terms of symbol. So I just do 15 pi as my answer with inches. If they're wanting it in terms of a decimal, which is the nearest tenth on this case, I would then get my calculator out, and this is where I would go ahead and put in pi as my number on my calculator. So if they want it in a decimal, then I would type in 15 times, and I use the pi button right here for that, and I hit equals. Now, some of you already know that pi is 3.14 when it's rounded to the nearest hundredth. Unless they tell you that, do not use 3.14. Make sure you actually use that pi button, okay? So then I'm going to round to the nearest tenth. So I look at the number behind there. It is below 5, so this is going to stay as it is. So that's why it's going to be 47.1 inches. So this answer is in terms of pi. This answer was rounded. Okay, let's take a look at another one. On the second one, notice that they don't give you the diameter, they give you the radius. So now I'm going to use this first formula, and I'm going to put 4 in for the radius spot. So now I have 2 times pi times 4. Remember what I said, if it's left in terms of pi, I just ignore the pi symbol and multiply my numbers or simplify. So that's where I'm getting 8. And then I'm just going to tack the pi on at the end. So my answer in terms of pi would be 8 pi centimeters. My answer, if I had to round to the nearest tenth, this is where I will just type it into my calculator. So I would type in 2 times pi times 4. And I would get that. So then I round to the nearest tenth, so I would get 25.1 centimeters for my nearest tenth answer. Alright, you're going to pause the video and try the got it question. So in the got it question, the first one is using the radius, and it wants it in terms of pi. So you should be getting 2 times pi times 24, and if I'm leaving it in terms of pi, I would just multiply 2 and 24 and get 48 pi. The second one gives you the diameter, so I'm going to use the formula with diameter, and it wants you to round to this nearest tenth. So you would type into your calculator pi times 24 and get this decimal. In this case, I'm wanting to round to the nearest tenth, so in this case, when I look behind there, this is 5 and above, so I'm going to round up on this. So that's why it should be 75.4 meters. Make sure you're rounding correctly. Okay, problem number 3. They give us a picture now, and they want us to find the perimeter of that triangle. Now remember, we said perimeter is just distance all the way around, so we're just going to add up all the sides. But before I can do that, I got to know what all the lengths are. You'll notice that from here to here is just a horizontal line, so I can just count how many boxes I go across. So I don't have to find using the distance formula. So I just count 1, 2, 3, 4, 5, 6. So I found that GF is 6. Then this is a vertical line, so again I can just count those units by counting up through the boxes. And when I did that, I counted 8 for the length of that. So we found 6 and we found 8. Now we need to find the length of GE. Now this is not a horizontal vertical line, so we want to be as accurate as possible. So we can't just estimate by counting through there. We're going to have to use the distance formula. So if you remember, the distance formula was where we subtracted our x's and squared it, and then subtracted our y's, squared it, added those two together, and then found the square root. So if you wanted to, you can do it in several steps. So I break it down and I subtract these two, and then I square it. So I get 36 and 64. Add those two together, so I got square root of 100, and square root of 100 is 10. So in this case, I found that that slanted line is 10. So now when I'm doing the perimeter, all I need to do is just add up those 3 sides. So I found it was 6, 8, and 10 for my 3 side lengths, so I get 24. Now when they don't give you a unit label, you just write in units, or you can abbreviate it with the letter U. Okay, so that's just an application of what we've done previously. Couple more here, using the area formula for a rectangle. The only tricky part with this is paying attention to the wording. In this case, on problem 4, it says, here's a rectangular banner that's similar to the one that's on the right that you need to make. The banner is shown to have 2.5 feet wide and 5 feet high. To the nearest square yard, you need to figure out how much material you need. So how much material is asking me to find the area. And since they're wanting me to do it in square yards, I'm going to have to convert these feet into yards before I start. Now, not all the problems are like this where you have to convert them, but in geometry you really need to pay attention to details, and so pay attention if they're wanting you to change it or not. So in this case, they want me to change it to yards. So I know that 3 feet are in 1 yard. So to convert those, I'm going to take each dimension and I'm going to divide by 3. So I went ahead and I took my width, 2.5, and I divided by 3, and I got 5/6. And then I did 5 divided by 3 for my height, and I got 5/3. Now notice that I'm leaving them in fraction form. Do not write them as a decimal and round, because then you're going to get further away from the correct answer, which is called a rounding error. So make sure that you're leaving it in fraction form if possible. And if you need help finding out how to do that on your calculator, here's what you can do. If I took that 2.5 and I divided by 3, this is the decimal that I receive. If I want to take that decimal and change it to a fraction, do you see this button where it says F to D? It's in the light pink, so I'm going to hit second and then the F to D button and hit enter, and then it will show me what fraction that decimal turns into. So that's how I knew that it became 5/6. And then same thing with the other one. So now that they're both converted in yards, now I can go ahead and multiply them. So since it's a rectangle, we're doing length times width, or base times height. So I just typed into my calculator 5/6 times 5/3. And again, remembering that your fraction button is here. So if I typed in 5/6, I would hit 5 fraction button 6. Take that times my 5 fraction button 3. And that's how I got 1 7/18. So that's why I'm labeling my area as 1 7/18 square yards. Okay, I just wanted to show you that just because of the fact of these are kind of basic, finding the area of the rectangle, but you do want to make sure that you can convert those if need be. Okay, last problem, or sorry, a couple more problems. Area of a circle, just making sure you know how to utilize that area formula. So this asks what's the area of K in terms of pi. The area of a circle is pi times radius squared, and so we need the radius always to find this. So notice that they gave me the diameter. So if you remember, the radius is half of the diameter, so I would find the radius as being 8 in this case, and so 8 would be the number I would want to plug in for the R spot. This does ask me to leave it in terms of pi, so I'm going to cover up the pi and do any simplifying that I need to. So I would do 8 squared, which is 64, and then tack on my pi at the end and put on my label. So the area of this circle is 64 pi meters squared. Alright, last one. Last question is where just making sure you understand that if you get some really odd looking shapes, you should be able to cut those into different shapes that you know how to find the area of, and then just add all of those pieces together. So it says, what's the area of the figure at the right? You can assume all angles are right angles. So what I wanted to show you was you should be able to cut this into different rectangles or squares. So cut it into shapes that you know how to find the area of, but you might have to do a little bit of thinking in terms of the dimensions. For example, I know that this side's 9 and these congruency marks mean they are the same, so therefore this is also 9. And then it has all of these tick marks being the same, so I know that all of these end up being 3. And the reason that becomes helpful is because you're going to need to know this length here. But if I know from here to here is 3, and I know that from here to here is 9, I can add these different chunks up. So 3 plus 3 plus what has to be 9. These two add up to 6. So when I subtract away from my total, which is 9, this guy also has to be 3. The reason that's important is because when you find this entire length, I can add those two to get that it's 6. And then these have to be the same, so that's why it's 3. So you have to do a little bit of cutting and dicing and using some logic to figure out what those end results need to be. But the reason that's helpful is because if you notice in this picture, it's showing you that you cut it into either rectangles or squares, and then you found all the dimensions. So this top one ended up being a 3 by 3, so the area is 9. This one right here, which we just got done discussing, ended up being a 6 by 3. So therefore, the area is 18. And then last, I ended up getting a 9 by 3 rectangle, so my area was 27. So then I can just add those 3 areas together and get the total area, which is 54. Again, these shapes look kind of scary, but cut them into shapes that you know how to find the area of, and then find the areas of those individual shapes and add them together. Okay, I know there's a lot of going on in this section, but a lot of it's review, and I wanted to make sure I touched on it. So a lot of it has to do with perimeter and area, using circumference of a circle and area of a circle, making sure you can utilize all of those formulas.